Alright, let's have a look at the kinematic equations. These are equations you will have learned or you're going to learn. Now, you should memorize them. Basically, physics equations, they do supply them, but if you don't pretty much know the equation you're going to use when you're looking at a question before you look at that front sheet, then you don't know your physics very well. So I do encourage you to learn them. There are two kinematics ones for distance, and there are two kinematics equations for final velocity. So the distance one, VI plus VF all over 2 times t. Let's have a look at that one. That one, you can see what that is. A final velocity plus initial velocity divided by 2. That's an average velocity. So all this is a little bit of a repeat of d equals vt, but we've used an average velocity, right? So that's an important one though, because again, this is all assuming a constant acceleration. So these equations are not working for an acceleration that's not constant. So this one, often students don't see the relevance of it, but if we've got, in some of the problems they do, if we've got a situation like that, this is a VT graph, right? So if this is VI and this is VF, right? So we've got an acceleration, haven't we? And basically what it said is that VI plus VF, these two, divided by 2 times t will give you the distance. So it's basically said that with a constant acceleration, because that's what you're assuming, then the average velocity will just be divided by 2. And that doesn't matter what the acceleration was. So that's that one. We've got another distance one, which is VIT plus AT squared over 2. So again, that's assuming you've got this initial velocity, you've got an acceleration, right? And you can get the distance. But the thing to watch out with this equation here is that the A and the V could be opposite in sign, right? So I'll give you an example of that. When you throw, or when maybe a water rocket or something just blasts off the ground and goes up very high, it starts off with an initial velocity, right? And acceleration x down. So if we make down negative, so that is negative and that is positive, then the velocity that it starts with, maybe 20 meters a second, is positive, but the acceleration is negative. So when you actually do this little equation here, right, and if we've said that positive was up, then positive is up, and distance would be positive if it's up. So the VI would be positive and the A would be negative. So you need to remember how to do those little moving things around with your algebra. So those are your distance ones. VF equals VI plus AT. So you're going at a certain speed, you then get an acceleration. The acceleration, if your velocity was positive, your acceleration could be positive, in which case you're going to speed up from that initial speed. But if it was negative, it means you're going to slow down. And it's just going to give you a final velocity. Probably the most used one isn't just VF, it's VF squared equals VI squared plus 2AD. That one is, again, very commonly used, because often in your problems, and we're going to be using these guys a lot in our projectile problems, often with this, say a projectile again, VF at the top is 0. VI was whatever it was. It will be a positive velocity up. But the acceleration, as we've said, if you've said positive up, is negative down. So for a given initial velocity, you can work out how far it will go, assuming A equals 9.8. Or, given a distance up, you can work out what its initial velocity is. So once you've got initial velocity, you could go back to another equation. We know it's final velocity up there, is that? But if I wanted to figure out the time, so given the distance, I can figure out the initial velocity, then I can use the initial velocity to work out the time to get up to its maximum height. So you nearly always, especially in projectile problems, have to at least use two of the equations, and you've got to decide which one are you going to start with. Okay, that's our kinematic equations.